Alright, what's going on, YouTubers, garage gangs? We got the old dart in the house here, smelling the garbage pile. And then we have the Volkswagen motor over here. I got a couple questions and I figure I'll answer them on this motor because it's here and it's pretty much at the right time to answer the questions. The first question was, why don't you install the flywheel before you install the crank on the motor? And what a lot of people do is they'll build their crankshaft and they'll put the rear bearing on and they'll put the flywheel on and they'll take a feeler gauge and they measure the end clearance between the rear bearing and the shim or the flywheel and set the end plate before they lay the crank in the motor. I like to put the flywheel on last, and I'll explain to you why I was taught to do it that way. And the guy that asked me the flywheel question, which I never mind a question, but I looked in the inbox, and a lot of times if it's sort of a hostile email, it'll go into the spam section. And a lot of time, if you're just a regular subscriber to my channel, if you put a comment in the inbox, it goes into the spam section. So I started looking in the spam section because somebody pointed this out to me, and the first time I did it, I found about 200 of my regular subscribers that were jammed over in there, and I okayed all their messages. And I checked it the other day and I had one hostile guy, and I thought I would go ahead and address him too, but he said I didn't know dick about rocker arm geometry. So I might be doing it wrong, and I might have been taught wrong all these years, I don't know. But I've had pretty good luck at it, not only with the Volkswagens, but with, alcohol Hemi motors and stuff that turn 13,000 RPM. I've never really had a valve train failure, but we'll go over it, what I know, and I'll show you what I have here. I have a dial indicator. That's an instrument that's used to measure the total lift, or the end play on the crank, or various different measurements. What you want to do, the way I was taught all these years, was if you have a cam that has 400 lift, we're going to use rounded off numbers for easy math. You go half of the lift of the cam, which would be 200, is what we'd be looking for on the gauge. So we're at 200, and when the rocker arm geometry is correct, you want the adjuster to be parallel with a push rod tip. And that's about as parallel as you can get. This is a C35 scat cam, and the rocker arm geometry really never becomes an issue with this kind of setup. It's when you get into the more 600 plus lift cams, and usually if it's a high lift cam, that's when you start having to make push rods and set your rocker geometry up. Now, the guy mentioned rocker arm geometry, and he talked about a couple different things, and then he talked about the placement of the adjuster on the tip of the valve. That's a sweep. It's not geometry. You can set that with a magic marker. Usually, this is pretty much set for you by where the rocker is located on the stud. Now, if you're in a really custom situation, you can address this with different ratio rockers. You can move the rocker stands out, or you can weld the head up and relocate the stud and change where the rocker is located. They make a couple different things in the Volkswagen world to address this, and in the American car world, they make lash caps, which gives you more surface on top of the valve tip. And some rocker arms require that you run a lash cap, such as a high lift, because it has a pad up here and the adjusters move to the bottom. We're dealing with a stock rocker here, and you can't really see because this has got some grease on the lash caps, but the adjuster's pretty much dead center in the valve. And the other way that you adjust this is the shims in the rocker shaft. You can move it left or right with shims. You can't move it up and down. That's only done by moving the stud and the head. Most people don't have the the equipment or the ability to move the stud. Now, I've worked with people that did, and it's a pretty lengthy process. You sort of hope that the stud's mounted in the right location from the factory, and you can set your geometry by the length of the push rod and the shim that goes underneath the rocker arm. So anyway, that's what I know about rocker arm geometry. I'm sure there's people that know more, and stuff's changing all the time. That's pretty basic, and it's just a form of measurement. So that's how I do it. If I'm wrong, you can make a video and show me your way. The other thing is, why don't you put the flywheel on? And I told you I like to put that on at the last possible moment, and I'm going to show you why. Let me set the camera down on the camera stand here, aka paint can. I think you can see that pulley. I'm going to try to go slow. I'm going to move this gauge off of here. I think we're done with the rocker arm geometry stuff. But anyway, I'm going to put this back on top dead center now because I have to put the drive gear in next. That'll lead us to question number 3. So I'm going to make sure this is on top dead center. I'm going to make sure both rockers on number 1 are not moving. Now when I move this crank, I want you to watch this pulley move. You see it move? You see it move back. You can hear the clunk. That's telling you that the main bearings are not pinched. The biggest mistake a lot of people make when they build a Volkswagen motor is they smash the bearing onto the dowel pin. And when you do that, it's very easy to miss it. You can turn the motor over, and a lot of people mistake a tight motor with a new engine. The motor should never be tight at any point or form in the assembly process. You will start to get resistance when you add the valve springs and rocker arms and spark plugs. But when you're spinning the assembly over up to the point where you put the heads on, you should be able to turn it over with your hand. This is the same for an American car. Unless you incorporate a rope seal instead of a neoprene oil seal, the motor should rotate pretty freely. The tighter you make the bearing clearance, the thinner the oil is going to have to be. But the reason I don't put the flywheel on is so I know that this crank floats through the main bearings right up to the point where the motor is ready to put the flywheel on. I am very positive that everything is good inside this motor because I have crank float, and you want the crank to move back and forth in the case until you set the thrust. If the crank's bound up in the case while you're rotating it without the flywheel on, you know you need to pull it back apart and start the process over, that you've pinched the bearing somewhere or you have some sort of issue in there. A lot of times if you choose to go with a counterweighted crank, you'll run into the issue of the counterweight hitting the center main. We ran into that on the Porter project. If the counterweight gets welded on crooked, or if it's a one-piece crank and it's cast off a little bit, Volkswagens didn't come with counterweight cranks, so a lot of times that can be an interference issue that you have to make do for. You have to clearance the case a lot of times. The last thing is the installing of the distributor. There's no really good reason for this part. It's just the way that I was taught. And there's people out there that install the distributor in this half of the case before they put the other case half together. And there's nothing wrong with that. That's totally perfect procedure if you do it that way. I was taught to do it this way. And I don't like doing this. It's probably one of my least favorite things to do. I've always thought about putting the distributor and building that out for the case before I assembled the two case halves, but I just never have done it because I wasn't taught that way. That's the only reason. When you go to install this gear, you're going to have shims that go under the drive gear. Now these shims ride between the case and this section of the drive gear. And what this does is it shims this up into your distributor. And if you leave these shims out, you'll have really bouncy timing. Your timing will fluctuate and this gear will bounce up and down in the housing where it goes. These shims hold it tight, and it basically adjusts the bump. If you ever set the bump up in a an American car distributor. Now this part isn't for the faint of heart. A lot of guys use 2 shims. I like 3. Somebody said that, hey man, Volkswagens only came with 2. There again, I put 3 in all my life because that's how I was taught. They take 3. And I pulled plenty of motors apart that have 3 in them. The only exception to this rule is a lot of times the Brazilian and later Volkswagens will have a spacer instead of a series of washers. And in that case, a lot of times you'll find 1 shim and 1 spacer. We have 3 shims today, and we're going to go ahead and drop these bad boys in. I'll show you how to do it. Like I said, it's not for the faint of heart. You should probably do it the other way if you haven't ever built a Volkswagen motor. This is one of those things in my videos that you probably don't want to copy. I put the shims on a screwdriver like so. You need a long screwdriver, it'll fit down into the case. And I'm not going to use a flashlight. I've done this a couple times. It's pretty dark down in there. But there's a hole, you drop it all the way down in that hole, and you drop the shims in there. And then you go around and around and around and get your shims flat and pull your screwdriver out. Now I have to tell you, if you make a mistake at this point, you're taking the motor back apart to get those shims out because they are super hard and they will destroy anything that gets in their way. Especially the timing gears. That's the first thing they'll take out if you try to leave them in there. So I'm going to take this vacuum advanced distributor here and use this for setup. Basically I'm positioning my rotor for number 1. I want number 1 to be over here, so this is an offset gear on the bottom of the distributor. And so is the top of the drive gear, so you need to position it in there where your rotor is going to point the right direction. That's how they should fit together when you have it right. If you try to put it on backwards, you'll see that let me see if I can do it. You see how the gear sits off to the side? It's not parallel with the bottom of the distributor. You don't want this. You want it to be this way. It should be perfectly straight and lined up. So anyway, you want to take your distributor where you want it, where you want number 1 to be. Position your gear. So we're getting the position of the slot. And we're going to stick this down in there. And there we go. And you just pop the distributor in and make sure that it's where you want it. It's right where we want it. There we go, all the way in. We'll install our spring in there and we'll be ready to put our distributor in. Like I said, it's probably better to build the case halves, put that in first, clamp your distributor down and all that stuff. I've done it like that 1,000 times, so it's not very scary to me. So I put a little bit of grease on the drive gear because it goes into a brass gear, and until it gets some lubricant on it, you want it to have something on there. But anyway, now that we have the drive gear in, we can go ahead and install our fuel pump next. Put our block in, our rod, and our pump. Our rod is what rides on the drive gear. That also works the fuel pump too. So it drives the distributor and works as the fuel pump fulcrum. But anyway, we're winding this one down. We're just about done with this. I'll finish this up for Noel and Todd. And hope that explained thing on the rocker arm geometry. We'll get into more elaborate setup on the 2110. When I build that, it has Berg rocker arms. And I'll show you this at a high lifts how the adjusters are turned around. Here's a set of Berg rockers. These are some 1.5s. You can find these used. You can pick them up for about $1,000. I think this is probably the best rocker out there. A lot of guys like the Potter rockers, but they break, and these don't break. So, but you can see the pad up on the top there. That rides on a lash cap, and it's got the cup at the bottom for the push rod. So it moves the adjuster from the stem of the valve to the push rod. And then you have a much broader pad up here for higher lift cams and such. And you incorporate a lash cap with that, and you get quite a sweep area. So rocker arm geometry and sweep on top of the valve are two completely different things. And they're both addressed different ways. So hopefully that clears that up. And I thought I answered it pretty civilly compared to the email that I got. So anyway, hopefully that helps you out. And if you're doing it wrong, maybe you can do it right now. And if I'm doing it wrong, maybe you can make a video and show me how to do it correctly. So the other argument that we've gotten into a couple times in the garage is oils, different oils and stuff. And clearances on bearings, that's probably one of the most frequently asked questions. How much bearing clearance do you run? And that's sort of really determined by the application of the motor. A lot of guys talk about a thousandths or a thousandths and a half bearing clearance, and I've run as much as 2.5 here. I like 2. 1.5's a little on the tight side for me. It limits the motor oil that you can run. And I'm not a sewing machine oil guy. I like a little bit of oil wedge between the part and the bearing. And if you guys aren't familiar with the term oil wedge, that's the amount of oil that's between the bearing surface and the crank. So a lot of people think that the actual bearing rides on the surface of the crank. So when you bolt a bearing onto this crankshaft, it never touches the metal. The first time that happens, you have failure. There's always a film of oil there. And the clearance that you set when you have the crank turn, if you go to the machine shop and tell the guy, hey man, I want 1.5 thousandths, 1 thousandths bearing clearance, you're going to be running a 1030 or a 30 weight oil to get enough film in between the bearing and the surface of the crank. And when you reduce the clearance down to 1.5, 1 thousandths, you have very little bit of oil wedge between the bearing surface and the crank. Now recently I've watched a video on YouTube. The hot rod guys over there at Hot Rod Magazine have a 55 and they're building a 710 cubic inch Sonny Leonard motor. Those are more like the engines that I used to work on before I came home from racing. And if you go in that, the shop manager takes you through the building process, how they set rocker arm geometry, how they set bearing clearance, and they like 4.5 thousandths bearing clearance between the bearing and the crank. That's a big wedge of oil. And the reason they do that is because every race team out there that runs a pro mod or an alcohol funny car or a top fuel car is running 70 weight oil because of the load in the cylinder. So they're not running synthetic oil or something very thin that allows you to run very tight clearances. And anytime you tighten the clearance up, you stand a chance of damaging the part much sooner if you have an oil failure or a pump or any kind of issue, because there's very little cushion there between the surface of this crank and the bearing. That's why I like to run about 2. That's about as tight as I'll make a Volkswagen, especially being air-cooled in the environment that they run in. Anything thinner than that, the oil just gives up when the motor gets hot. Is what I found in my experience and the way I run my motors. I expect when I build a motor for somebody, they're going to turn it 6,500, 7,000 RPM, and they're going to run the dog piss out of it, almost like they stole it. That's why people build high-performance engines. Let's be honest. They're not going to put a motor in their car and baby it to the car show. But anyway, hopefully that explains a little bit about why I do those things people ask me about, and gives you a little better understanding. Sorry I couldn't use the Canon camera, but we'll get back to that. And you guys have a good day. Like and subscribe, and thanks for your support.